Hello! In this presentation, I'll walk you through setting up a system with two Arch Linux servers and a load balancer. The servers will be running a bash script to generate an HTML page loading system information. This system uses a timer so that the pages update daily and employs a load balancer to distribute traffic between both servers. We'll cover the key files in the GitHub repository, the commands to set up and test the servers, and the reasoning behind the script design choices. By the end of this tutorial, you'll understand how all the contents of the repository work together. In this repository, we have the following critical files. The server setup script, which is the main setup script that installs required packages, configures the system, and sets up services. The generate index script, which is a bash script that creates an index.html file with some system information. Finally, the generate index.service and generate index.timer files, which are systemd unit files to automate the executing of the script. These files are essential for setting up the web servers and completing the tasks that we have to do. Before running the setup, we have a few prerequisites to fulfill so that the setup completes without errors. First, we need to make sure that we have already set up two Arch Linux droplets tagged with the web title. In-depth documentation can be found on the Arch Linux and DigitalOcean websites. Similarly, we also need to make sure that we have a load balancer set up and linked to the web tag. A load balancer is a tool implemented either through software or hardware to distribute requests across multiple servers. Basically how it works is the load balancer receives incoming requests from clients and then distributes them to multiple backend servers in a way that can optimize performance and prevents any single server from becoming overloaded. It also makes sure to redirect traffic to healthy servers if one or more servers fail. In our use case, this diagram explains how it works. A client would send a request. The load balancer takes the request and routes it to a specific server based on its algorithm. As more requests are sent to the load balancer, it distributes these requests across the server network in a logical and efficient way. Having set up the droplets and load balancer ahead of time, make sure that necessary preparations on DigitalOcean's side are ready for when we make our changes to the servers remotely. Third, each server must be updated with the sudo pacman syu --noconfirm and sudo pacman-s arch linux keyring commands and restarted to update the entire system, IP tables, and all the rest of the necessary elements for the setup, firewall, and config stuff later on. And finally, all necessary files mentioned above must be uploaded to both servers. Once all of these are in place, we can execute the server setup script to handle the rest. Now, let's take a deeper look into the setup script being used. To run the script, type sudo bash server setup.sh in the terminal of each server. This script performs several tasks. First, it ensures that the script is run as root. This check makes sure that the script will run and do all of its tasks without being blocked by certain permissions that only the root user has. This is done using the if statement shown. Next, it uses the pacman tool to install the necessary packages for all the functionalities that we have to implement, such as Nginx and UFW. The Nginx package is a library that we're using for our web serving through Nginx, while UFW is our firewall library to use the uncomplicated firewall for our servers. Once all of the packages are installed, the next step is creating our new system user, WebGen. A system user is a special type of user in Linux. Unlike regular users, it lacks login access, meaning that the no login shell assigned to WebGen prevents this user from logging into the system directly, minimizing the risk of unauthorized access. This is achieved using the -s user sbin no login in the user-add command. A system user also runs services securely. By assigning ownership of the WebGen directories to the WebGen user, we isolate these resources from the other users and applications. For example, the Nginx web server runs as WebGen, ensuring that if Nginx is compromised, the attacker could only gain access to the limited privileges of WebGen user on our server, and not to the root account or other critical areas of our system. Finally, using a system user ensures simplified permissions management, which means that by assigning all files and directories associated with the generate index script and Nginx config to the WebGen user, any changes are automatically scoped to WebGen only, which makes it easy to adjust permissions because it all just falls under the WebGen scope and doesn't affect other files in the system. After setting up WebGen as a system user, we now have to create the necessary directories for WebGen and Nginx. From our assignment specifications, we needed to create these bin, document, and HTML directories, which will store our example files, the generate index script, and the HTML document, all within the WebGen home directory. Also, We created the Sites Available and Sites Enabled directory system, which is recognized by Nginx, so that if we were to expand our server with more server blocks, it makes it easier to manage all the server block files and isolate certain issues to a certain parts rather than creating issues for the whole server. With those directories in place, we also created sample files in the Documents directory as instructed. After the directories are created, the generate index script has to be moved into the bin folder within the WebGen home directory. Once the WebGen directory structure is set up and files are put into the right places, we now have to change the ownership and permissions of the generate index script and the overall WebGen home directory and files inside, so that WebGen has the configuration to use the contents of its home directory without running into any ownership or permission issues. Once these are finished, we can now start configuring Nginx. The changes made to the Nginx file are based on the documentation listed in the references at the bottom of the README. The first step of setting up Nginx is to modify the webgen.conf file. This is the core configuration file for Nginx that dictates how it handles web requests, resources, and overall server behavior. The script writes a custom nginx.conf file to replace the default configuration, which tailors it to our specific needs. The first step is renaming the user to WebGen. This line specifies that Nginx should run as the WebGen user instead of root. By doing so, we enhance security. Even if an attacker exploits a vulnerability, they are limited to the permissions of the WebGen user. This ties in directly with creating the WebGen user earlier on. The worker processes auto directive tells Nginx to automatically adjust the number of worker processes based on the number of CPU cores. Worker CPU affinity auto makes sure that CPU utilization is efficient by binding worker processes to specific CPU cores. These settings optimize performance, especially under heavy load, by ensuring each worker gets dedicated CPU resources. The multi-accept on directive allows each worker to accept multiple new connections at once, improving responsiveness. The worker connections directive limits each worker process to handle a maximum of 1,024 simultaneous connections. This prevents resource exhaustion and ensures stability under load. Now moving on to the HTT block. The HTT block contains configurations specific to web traffic. The first section refers to the MIME types. These lines ensure Nginx properly recognizes and serves files like HTML, CSS, JavaScript, and images by setting appropriate MIME types. The fallback type application/octet stream is used for unrecognized file types, ensuring safe and consistent handling. Access logs track incoming requests, while error logs provide insights into any server issues that might be encountered. Setting the error log level to warn reduces unnecessary noise from issues while still capturing important warnings. After applying our custom nginx.conf file, we're also going to create a server block for WebGen called webgen.conf. This file defines a server block specifically for our WebGen project. Server blocks are essential in Nginx. They define how the server handles requests for a particular domain, path, or application. Listen 80 specifies that our server should listen for HTTP traffic on port 80, the default port for unencrypted web traffic. Server name defines the domain or host name that the server block is responsible for. The root directive sets the base directory for serving files. Any files requested from the server are resolved relative to this directory. In our setup, /var/lib/webden/html is the directory where we'll generate and store web content, aka the index.html file we will be generating later on. The index directive specifies the default file to serve when a directory is requested. In this case, index.html is our default page. The location / block applies to all requests made to the root URL, which is /. The try files directive tells Nginx to serve the requested files if it exists, which is the $URI, and if a directory is requested, serve the directory's index file, $URI/. Otherwise, return a 404 error. This ensures clean URL handling and avoids exposing server internals through poorly configured error handling. Similarly, the location/documents block is a specialized location for handling requests to /documents. The auto index on directive generates an automatic directory listing if no index file is present. The final step with setting up Nginx is to activate the webgen.conf configuration. To do so, we create a symbolic link in the Sites Enabled directory with this command. Then, we just have to use systemctl to enable and restart Nginx. Once all of Nginx has been set up, The script then moves and enables the generate index service and timer files. The generateIndex.service file defines the systemd service that will execute the generateIndex script, which is responsible for creating the index.html file. Within the unit section, the description provides a brief description of the service. In this case, it indicates that the service runs a script to generate an index.html file. The once directive will try to bring up the multi-user target as part of its startup process, even though it's not mandatory for the service to run. Within the service section, the user and group specifies that the service will use webgen to determine permissions and run under webgen. execstart defines the command that executes when the service is started. Here, it runs the generateIndex script. Restart tells the service to only restart if it fails, i.e. on failure, and type one-shot tells the service to run to completion in a single execution and does not run ongoingly. Once the generateIndex script finishes, the service stops. The wanted by directive under the install section defines the target that the service is linked to. It will be started when the system reaches a multi-user run level. For the timer file, the description is the same as before, describing what the timer does. The onCalendar directive in the timer section specifies the interval that the timer is going to activate, and the wanted by timer links the timer to timers.target, which is the systemd target responsible for managing timers. One thing to note about the script is that it expects that all necessary files are in the same directory as the script, so make sure that all the files are together. If the generateIndex script, timer, and service files are not in the same directory, then the script will run into errors. Once the service and timer files have been moved, we must now use the systemctl tool to reload the daemons, enable the timer file on boot, and start both the timer and service files. The last major task that the script accomplishes is setting up the firewall. With UFW already installed, we must first allow SSH and HTTP, but also limit SSH. These commands allow connection via SSH and HTTP, but make sure to limit the rate of incoming SSH connections to mitigate brute force attacks. Systemctl is then used to reload daemons and then enable the UFW service on boot. Finally, UFW is enabled, and the last command before the success message is to show the firewall status in the terminal to check for errors. That's it. We've successfully set up 2 Arch Linux servers with a load balancer, automated HTML generation, and a secure web server configuration. Thank you for watching.